So today we're going to go ahead and talk about the difference of elastic versus inelastic collisions. And keep in mind, we know that momentum is conserved if there are no net outside forces. Okay, so in elastic and inelastic are both different types of collisions where momentum is conserved. So keep in mind for both of these types, momentum is conserved. Another thing that is always conserved is energy. We know that energy is always conserved. Energy conserved. Sometimes energy may be converted to like non-mechanical forms like energy lost due to friction or other things, but energy is going to be conserved. Okay, so in an elastic collision, the objects never stick together after the collision. And I think to myself, like elastic collisions are bouncy. Like elastic objects, like a rubber band that'll like bounce, like kind of thing. Elastic objects are bouncy and just will never stick together. While inelastic collisions aren't quite the opposite, but objects may stick together or they may separate. And either of those things could happen. So sometimes if objects don't stick together, if they separate, it could be either elastic or inelastic, but if they stick together, it has to be inelastic. So last little thing to really calculate elastic versus inelastic, if they both like bounce, you don't know right off the bat. In an elastic collision, all the initial kinetic energy is converted to all the final kinetic energy. So kinetic energy is conserved. While inelastic collisions are the opposite. The initial kinetic energy does not equal the final kinetic energy. So some initial Ke is converted to other forms of energy. Okay, so let's think to ourselves, like an inelastic collision, where is some of that initial kinetic energy converted to? One example that I think about is an inelastic collision is like a car crash. So in a car crash, the two cars may stick together or they may separate, but in either case, it's going to be inelastic. Like I think of cars sticking together as like slower, like going on like, a regular old road, like regular old street, and they might just crash together and stick together. While sometimes I think of like two cars on a highway, which is really scary to think about, and they may like hit each other and bounce off and go flying totally different ways. But either case, it is a car crash that's inelastic. So some of that initial energy Ke goes to other forms. So let's think about what it goes to. So some of the initial Ke will go to, let's see, what do you see or observe in a car crash? So it'll go to sound energy. It'll go to like thermal or heat energy. And again, a lot of that thermal and heat energy is like energy converted from like friction kind of thing. Awesome. So we're going to go ahead and solve two problems to figure out if they are elastic or inelastic. Okay, so what I want you to do is go ahead and try this one yourself, draw a before or after picture, and then check back into the video. So I'll go ahead and do it here. So let's go ahead and draw a before picture, and let's go ahead and draw an after picture. So beforehand, we have 2 kilogram pool ball, moves to the right, 3 meters per second, crashes into 3 kilogram pool ball that was going to the left at 1 meters per second. Let's see. Afterwards, a 3 kilogram ball has a velocity of 2.2 meters per second to the right. We want to know what the velocity is of the 2 kilogram ball. Cool. So let's go ahead and figure this out. So beforehand, we have, silly mistake. I should draw my coordinate system. So we're just dealing with the x direction. So, and I'm going to say to the rightwards direction is positive. Cool. So we have momentum of 2 kilogram plus momentum of 3 kilogram equals momentum of 2 after plus momentum of 3 after. And again, we know our equation for momentum is mass times velocity. So I'll go ahead and just multiply mass times velocity for each one. So we have 2 times 3 plus 3. This 1 is going to the left, so I'm going to call that -1. equals 2v plus 3 times, this is going to the right, so positive 2.2. Cool. I go ahead and do some good old math, and I get the velocity of the unknown to be negative 1.8 meters per second. Okay, I guess that makes sense because afterwards, it kind of makes sense as this 2 kilogram is going to bounce back in the opposite direction. Cool. So physics just told us how it should work out. That's nice. I like that. Okay. So now let's go ahead and see if this is an elastic or inelastic collision. So the two objects don't stick together. So we know it could be either elastic or inelastic. We don't know from there. So let's go ahead and calculate the initial kinetic energy and final and see what happens. So initial kinetic energy. We can just calculate the kinetic energy of all the things on the right-hand side. So, and we know kinetic energy, it's a scalar, so it's always going to be positive. So it's what? The 1/2, okay, so it's what? 1/2 mv squared of the 2 kilogram plus 1/2 mv squared of the 3. So let's go ahead and plug everything in. So 1/2 mass is 2, velocity is 3, 1/2 mass is 3, velocity technically -1, but a negative squared is just a positive. I go ahead, I get 9 for the first one, 1.5 for the second. So the total beforehand is 10.5 joules. Okay, so let's go ahead and do the other side. KE final. So same idea, we have two separate objects. So we'll just add the KE of both of them together. And again, if they were going totally, crazy directions, doesn't really matter with kinetic energy because it just is a scalar. So we have what? 1/2 mass is 2. Velocity of the 2 was negative 1.8 squared plus 1/2 mass of 3 times what? 2.2 squared. I plug it into my handy dandy calculator and I get 3.24 plus, what is this? 7.26, and I get 10.5 joules. Cool. So in this case, the initial KE does equal the final KE. So in this case, we know it is an elastic collision. Cool. Okay, and I said we were going to do two problems, but I realized let's just do one problem and talk about it. So let's say we have the exact same situation, but let's say that the initial kinetic energy, I changed some numbers around, the initial kinetic energy, let's say that it turned out to be 20 joules. So just hypothetically. So let's say initially it was 20 joules, and at the end it was still 10.5 joules. So in this case, if you have 20 joules at the beginning and what, 10.5 joules at the end, that means that all the initial KE does not equal all the final KE. So in that case, it would be an inelastic collision. And again, that would be a different situation, different problem, saying initially, let's say it was 20 joules. So, okay, and they could still bounce apart and it was still like inelastic. So let's think about that. 20 initially, 10.5 at the end. So some energy like went to the environment. It went to heat energy or sound energy. We lost some energy. So if we had 20 initially and 10.5 at the end, let's just calculate how much we lost so that we can just subtract those. So we would lose 9.5 joules lost to it could be heat, it could be sound, it could be all those things. And instead of lost, I should use the word transferred to different forms of energy. Awesome. Thanks for watching.